All right, your job now is to, on the same sheet that we were talking about earlier today, graphing vertical and phase shifts of y equals sine of x and cosine of x, we've already talked about. Part one, I would like you guys to move down to part two. Move down to part two. We're going to talk about phase shifts. The graph of y equals sine of x minus pi over 3 will have a phase shift up. Now, phase shifts just mean that you, or take a guess, you guys, what does phase shift mean?
To the side.
You are moving the graph to the left
All right.
or moving it to the right.
So you're multiplying, you're dividing it then, right? Subtraction, adding.
Well, remember when we used to do like for instance, if we had a graph that looked like this, if you had to graph
I didn't understand that stuff. I think it's-
if you had to graph y equals x squared, that was just a parabola
Yes.
that did this. But then if we threw an x minus 3 next to the x and squared that, what did that do to the graph?
Am I
You
going
moved
up
it
and
somewhere
down?
3 times.
It moved it somewhere 3 units. Where did it move it?
No idea.
It actually moved it in the opposite direction of what you thought it was going to move it. So if it said x minus 3, you probably would think it would move it 3 units to the left, but it actually moved it 3 units to the right instead. Exactly the same thing happens with this stuff.
No, that's not.
So the graph of y equals sine of x minus pi over 3 will have a phase shift of, what is the phase shift going to be? Take a wild guess. It's going to be pi over 3. This number right here is your phase shift. Now it says minus pi over 3, so you think that it probably would shift it to the left, pi over 3, but it's actually going to shift it to the right. So it has a phase shift of pi over 3 units to the
Right.
To the right. If y equals a, the sine of bx minus c, and y equals a, the cosine of bx minus c, the amplitude is what? What number represents the amplitude?
Hey,
It's going to be the a.
that's not
And the phase shift is what? What is the phase shift?
The period is the
Negative C.
Oh, the period is. Oh, sorry. You know what?
Oh,
I saw that and it's like the period is. What is the period, you guys?
BX.
No.
Wait, what are we talking about? B.
No, it's not b.
What's that?
b is the number that you use to find the period. Remember, the number that goes in front of x is the number that you use to help you get the period.
So 360 divided by b.
So it should be 360 divided by b, but don't write that. Why am I not writing 360 divided by b?
2 pi.
Yeah, because this has a phase shift of pi over 3. So the period is going to be 2 pi divided by b. And the phase shift is, what is the phase shift?
Minus
C.
Should be
C.
C. Very good. The right and the left endpoints of one cycle interval can be determined by solving the equations for x. So, this is what you need to do. You normally have the left endpoint and you have the right endpoint, which always match each other. Are you with me here?
Yeah.
Okay, so when you have a situation like this where you have a phase shift that moves the graph left or moves it right, what you need to do is put all of your stuff equal to what the endpoints normally are. What are the endpoints normally?
0.
They're actually equal to 0. 0 and the other endpoint happens at 2 pi. Normally, in a normal curve with a normal period. So in this case, what we're going to do is take this stuff, the bx minus c, that's what I mean by stuff, bx minus c, and we're going to put it equal to the left endpoint. And the left endpoint normally is equal to 0. And then to find your new right endpoint, you have to take your stuff, which is bx minus c, and you need to put it equal to the right endpoint, which is what? It's 2 pi. And we need to solve for
Just
x. What do we do to solve for x in this first one? We're finding the left endpoint.
Divide B.
Well,
Add
we add
C
c first.
Okay.
Okay, we add c first. So we
Okay.
have bx is equal to c, and then we have to divide by b. So x is equal to c divided by b.
Mhm.
Guys, I just realized over here too, I put pi.
Yeah,
I
I
meant to
noticed
say
that,
two
but
by-
you didn't say anything.
Sorry, I meant to say 2 pi. Alright, in this case over here, to solve for x, we are going to add c and add c. So bx is equal to 2 pi plus c, and then we have to divide that by b. So we're going to take 2 pi, we're going to add c to it, get an answer, then we're going to divide that by b.
Okay.
I didn't see.
And
So we are running out of time, and I do know that. Really quickly, what's the amplitude? Yep. Our half. What's the period? It's 2
2
pi divided by whatever is right in front of x. What is right in front of x?
a parenthesis.
A parenthesis, which is 1. So the period in this case is equal to 2 pi. Now, the phase shift. What is the phase shift, by the way?
Minus pi over three.
Pi over 3.
Pi over 3. Now, let's do this. Pi over 3, are we going to have, is the graph going to move right or going to move left?
Right.
It's going to move right. It says minus pi over 3. It always moves in the opposite direction, so it's going to be pi over 3. I'm going to put a little r there for right. Pi over 3 to the right. Now, to find the left endpoint, you got to take this stuff right here. And what do you put it equal to?
0.
You put it equal to 0. That's an easy one. What's x? Over x.
Equals,
Oh, wait.
Add
or
add pi over
X is
3.
equal to
Add pi over 3. So x is equal to
Pi over three.
pi over 3. Over here, you're going to take x minus pi over 3. What do you put it equal to?
What?
Put it equal to 2 pi. So x is equal to 2 pi plus pi over 3. So what you need to do here, you guys, ignore the pi's for a minute. Add together 2 plus 1/3. 2 plus 1/3. Give me a nice fraction back as your answer. What is 2 plus 1/3? 7/3. So you're going to end up with an x value, an end value of 7 pi over 3. So you know your graph is going to start, kind of like start at pi over 3. It's going to end at 7 pi over 3. Again, we have a period of 2 pi. Okay. Little practice